one time and come back to its original position in a period of 24 hours. That's how we define a day. Like right now, the sun is high in the sky, it's almost noon. So the next day, the sun will come back to that same position in 24 hours. And that's called a mean solar day or a tropical day. Tropical, why? Because the sun is measured by the tropic or the longitude that it appears at. However, that's not the only thing that's moving. The Earth is rotating every 24 hours. But in 24 hours, it also moves to the next position. And so for the sun to come back to the same exact position relative to the Earth actually has to rotate for approximately 4 minutes of arc. More every single day. Okay? So if we were measuring the length of the day, not by the sun, but by some distant fixed star, okay, then our day would actually be a few minutes shorter. In fact, it turns out actually 23 hours, 56 minutes, 4.09 seconds, to be exact. That is a sidereal day. Sidereal means by the stars. So if we measure the day by the stars, we get a different length of the day than if we measure by the sun, the solar day. Okay? So solar time is going to be a little bit different from sidereal time. Why is this important? Because we measure the chart by sidereal time. Is Steve here today? No, Steve's not here, is he? Steve is our astrological programmer. And he's gotten all tangled up in this because he has to compute the sidereal time in order to cast the chart. So it's a little bit tricky. Fortunately, we have a program that does it for us. But anyway, the sidereal time will give you the positions of the stars relative to the Earth, whereas the solar time will give you the position of the sun. That sounds sensible, doesn't it? Yeah. But they're different times. For example, if I say we're going to have the meeting at 11 o'clock Central Standard Time, then if you're in Germany like Florian, the meeting is like 5 o'clock in the afternoon or something like that. Similarly, the difference between sidereal time and solar time adds up to 1 whole day per year, 4 minutes a day. Yeah, or about 1 day per year difference. So to get the accurate positions of the stars, you have to know the sidereal time. The calendar uses solar days. Right.
That's why we get out of phase.
Yeah, well, that's not the only reason. It's also because a year is not precisely 365 days.
There's a question from Randy. What is a reference star for sidereal time?
Oh boy, he would ask that. Let me see. Well, in Vedic astrology, we used the first degree of Aries, or Revati Nakṣatra. Revati Nakṣatra is the end of the Zodiac. And so that star, that actually is not there's no star there, no visible star anyway. It's a position on the Zodiac, and that is used as the reference in the Vedic astronomy for sidereal time. Now here we start to get into the difference between the solar and the tropical and the sidereal year. The Earth revolves around the sun every 365 days, 5 hours, 48 minutes, and 46 seconds. Write that down real fast. From the point of view of the Earth, this appears to be the sun making one round of the 12 signs in the Zodiac. But is that really a year? Just as we have a parallax difference between the measurement of a solar day and a sidereal day, we have the same problem in the measurement of the solar year and the sidereal year. When the Earth regains its similar position to the Sun after a period of 1 year, this is called a tropical year. But if we consider the position of the Earth with reference to the fixed stars, there's a difference of 50.26 seconds of arc every year. This is called the precession of the Zodiac. The precession of the Zodiac. And this is very, very important. This is a 26,500 year cycle. Why do we have this difference of 50 seconds of arc every year? Because of the wobble of the Earth's axis. Okay. The precession, as I said, it takes approximately 26,500 years. Just like a top. If you have a top rotating, and then as it winds down, it begins to precess around. I wish I had a movie of this. It would make it really dynamic and intuitive. But the Earth does the same thing. Remember, there's this 23.5 degrees difference between the Earth's axis of rotation and sidereal North Pole. Okay? So, right now, the North Star is Dhruvaloka. Right? But in many, many years from now, about 13,000 years from now, it's going to be Vega, the star Vega. And of course, all the star maps and the constellations and everything is going to change. It's going to be a big mess, but I don't think we'll be around to have to deal with it, so that's fine. This is, again, the difference between Eastern and Western astrology, or Vedic and sun sign astrology, is that Western astrology considers the vernal equinox to be first degree of Aries. But the vernal equinox is movable in comparison with the fixed stars because of the precession of the Earth's axis. And in the last 3,000 years, it's moved about 23 degrees, almost one complete sign of the zodiac. So this is a source of endless confusion because the translations of Vedic astrology that are the basis of Western astrology all assume that the vernal equinox is first degree Aries. Regardless of where the stars are. Who cares about the stars? So they've gotten themselves all mixed up. Whereas we see in Vedic astrology that a particular star, which is the beginning 0 degrees Mesha, the Rashi of Mesha, is used as the reference for the sidereal year. And that is considered 0 degrees Aries, or 0 degrees Mesha. And everything is measured from that point. And since that point is a sidereal point, it doesn't change. I mean, the Earth's axis can precess all that it wants, or the Earth's orbit can even change or whatever. Doesn't really matter. Even if we have a pole shift or anything, that is still going to remain the reference point for the zodiac because the plane of the solar system is not going to change. And that's our reference. That is our 0 point for all our measurements in Vedic astrology. And that's another reason why it's so accurate.
Are we at the end of or at the beginning of a precessional circle? I think 2012 and galactic alignment.
Well, is there an end or beginning of a circle?
No.
Not really. A circle is a continuous process. And so, similarly, the precession of the equinoxes is a process. It doesn't have a beginning and an end. You can't say that the first original point is any particular point. But we can say for the purposes of measurement, we select a particular point. It's just like the British selecting Greenwich as the zero longitude point. Huh? It's arbitrary, more or less. It's their choice. Huh?
When we have a fixed point, we have a beginning.
Yes, but the point is, the fixed point is arbitrary, and all the measurements from that point are relative. They're not absolute. This is the thing that escapes scientists and people who are trying to establish different kinds of truth or philosophical systems. There's always a point in any philosophical system or any system of terminology that is a fixed point to which everything else is measured or compared. And that point is more or less